Okie dokie. I do feel like the show is about to start. So once you arrive, if you could give us a little hello in the chat and your name, that would be, or hello from Arson, or hello from Galaxy A20. I don't know who that is. My name is Peter. I will introduce myself properly once we get started. If you are ready to rock and roll with some maths, I have a little question to get you started just while we wait for the others. So it's called a do now question. And so you can do that, but I'd love to know your name. And then I would love to know where you are in the country. Can you guess where I am? Okay. And I'll give a bit of time now for those who are still joining. Okay. Make that nice and small. And that's it. Okay, and I'm going to say, hello, everyone. Glad you all finally made it. It's time to get started. And please let your friends know too. How do you spell no? I hope I spelled it right. I'm not an English teacher. So just to clear up the mystery, I am located in Cape Town, in a small place called Fishhook. I refer to it as the deep south of Cape Town. And that is where I am. Where are you in the country? That is what I want to know. Okay, Elzana, are you still with us?
Yes, I am.
Fantastic. I see people are busy joining, so we will welcome them. They're probably all still figuring out if this is really the meeting or not. I don't see too much. You can answer by unmuting yourself in the chat. That is a good point. You want to be unmuted.
Yeah, guys, so feel free to unmute yourself if you, instead of giving your answer into the chat. Tell us where you're from. We'd love to hear, and we'd love to welcome you.
Indeed. Let's have a look. So we have, in the room at the moment, we have 6 people. So would that be, is that correct?
Yes.
Should I draw? You know what? I'm going to do some artwork on the screen while we wait for some people. And those who are ready for the math lesson, we will get started shortly. What I want to know, though, when you get here, is what is going on in this question. So while we wait for the others to join us, can you figure out the answer to this question? And then you will make your teacher very happy. Okay. So, Arson, if you're with us, can you let us know where about in the country you are? Are you in KZN? Are you in Gauteng? And then I see, who is the other one? Ah, from Cape Town, Belleville. Ah, I've been to Belleville recently. Welcome. Sorry about all the issues, but you know how it is. The first time you do anything, there's always going to be some fun and games. But we will, when we get started and we get everyone in, we will start the lesson. But welcome. It is really good to have you here. Who is the Galaxy A20? Hi, I think why others can join is because the WhatsApp text you sent us is busy saying invalid meeting ID to me. So I struggled. Thank you very much, Galaxy A20. You are an efficient, organized student. I can see this.
Yay, thank you.
Alzan, do you want to feed that back to the mothership or the fathership?
I will. I will.
Can you, Galaxy A20, what is your real name? Or is that, and whereabouts are you in the country? I'm interested to know. We'll probably get started in about a couple of minutes, 2 or 3 minutes. And then take it from there. Should I draw some more fun pictures? Let's see. I'm not an artist, I'm a math teacher, but who knows what I can come up with. Oh, there we go. Okay, well, in fact, submit your requests in the chat stream. What do you want me to draw? I will, this could be the funniest part of the lesson. Okay, let's see if I can draw a, okay, so I'm going to draw a soccer field. So there is my one side. Let's see how my 3D drawing skills are. So one of my favorite TV shows at the moment is Ted Lasso. And so I think I've got football on the brain. Let's see. Okay, and so now we need some people to play the football. Woohoo. Is it wrong that I'm having fun? Okay. Hi, Keke. From Potchefstroom, I take it. Welcome. It is nice to meet you, or to virtually meet you. Thank you for that information. It's quite valuable. Do you like soccer, Keke? Are you a fan of football? Okay. Have we heard? No, sir. What's your favorite sport? Or do you have a favorite cultural activity? Maybe I can draw that. As you can see, I'm a gifted artist. Oh, welcome to Dalen. I see you've made it in. So while we're starting to get a few more students, obviously I'm having a bit of fun while we wait for everyone, but I do want you to think a little bit about question 1 on, basically the first question is asking about which graph matches the story. And just while we get warmed up, you can have a look at that. And also I have another question that if it's not too small, that you can have a look at. And one of the things I'm going to talk to the students about is that every graph is really just a story. And so, you know, every story has different things that happen, and it has characters and things that happen. And so I'm going to take my football characters away, but I'd like you to have a look at these 2 questions. And just while we wait, just take out a pen and paper and just apply your mind to these questions, and we will talk about them. So, you know, the first question is fairly clear. The second one is a bit more open. What is the story of this graph, this orange graph over here? And I want you to just write down what you think the story is. What do you think is happening here? What are the major characters? If you were teaching someone else, what would you need to happen? That's what I'm looking for. Let's go with the eraser. Okay. Okay. So I'm just going to check Okay, so it says here that it may do not use the one in Notion. So we're meant to be using the one. So for my students who are still waiting, do you want to put the answer for the first one? So A, B, C, or D? Do you want to put the answer that you think is the answer for the question number one? So we have question number one. Question is D. Okay. Well, let's see if I agree with you, Awesome. So choose the graph that best fits the statements. House prices rose in January, and then they fell slightly in March. So if they rose, it can't be this one. It might be that one. It could be this one, could be this one. They fell slightly in March. So if they fell, both of these don't fall. And so I agree with you. So that is question mark. That is that. So absolutely perfect. Now, what I want you to do, Austin, is I want you to think of this next graph, and I want you to write down the story of what this graph says. And I actually want you to do it in words. And KK, if you could do the same, and if, let's have a quick look. I can't see the name on the, okay. So take a moment, see if you can tell me the story, think about what the story of this graph is. And if you're feeling very brave, then you can even, you can give us a verbal description and we can hear your awesome voice. If you feel willing, but it would be awesome. So everyone's thinking about this graph. What is the story of this graph over here? And then we'll move on from there. So Ozan, it does seem as if the most stable link for the video call is the one that I clicked on in Slack. Yeah? That's the one that seems perfectly stable.
Yes, Peter. I think that I'm just waiting for Emily to send me a message back now, but I think you can continue, and then whoever hops on, they can just watch the YouTube video.
Okay. I'm gonna go for it.
Awesome. Enjoy.
Okay. Cheers. Okay. So if I have some volunteers who are willing to give me the story of this graph, or what do they think is important? What stands out in this graph? Who is feeling brave? Okay. Okay. So what I'll do is I will tell you the story, and then let's just see if you agree with me. So when I look at this question, the two things, the major characters in this graph are temperature, which is over here, and time of day. So really, this graph is a story about how the temperature changes across the day. And so when I look at it, I see obviously that it's increasing on the one side and then it decreases on the other side. So that's important. So two words that you'll see come up a lot in graphing are increasing and decreasing. And the point at which, the increasing stops and the decreasing starts is going to be over here. Now, I don't know if you spotted that, but that is what I see. I also see that not all the information is on the scale. So I might want to kind of trace my steps back. If that is 5 in the morning, this would be 4, 3, 2, 1. So this would actually be 1 o'clock in the morning. And then it's going all the way, basically over the whole day, to 12 in the evening, or 24 hours. And so actually that there are these little dots along the way. And what these dots are saying is that this is when they measured the temperature. So we're sort of guessing the bits between the dots. We're approximating them with this thing over here, but really the dots are the valid points in which they have been measured. So over here, that is going to be 4 o'clock in the morning, and the temperature is going to be 11, 12, 13. So this point is 13 degrees at 4 in the morning. And if the story says it keeps increasing, so at 11, 12, so at 1 o'clock, the temperature is up to 15, 16, 17, 18 degrees. And so it basically keeps rising. The other thing I notice is that it rises the most probably between about 1 o'clock and 3 o'clock. And it probably falls the most in this patch over here, from this one to this one. Okay, so what I like to think about graphs, I always like to think about the story, and the characters in the story are temperature and time of day. And yeah, it's just good to just kind of almost draw some lines and get a sense of how the story unfolds. What did you think of my storytelling? Would you have added anything? Any extra words? What about the words axes? Would the words axes be involved? So some of you may have learned about this, but these two lines over here, this is often called the vertical axis or the y-axis. And over here, it's called the x-axis or the horizontal axis. And that's something to bear in mind. Okay, let's move on. So I'm going to skip the intro about me that I was going to do with the big group, just because I can just say it verbally. But basically, I'm in the Western Cape in Cape Town, and I'm very happy to be teaching this grade A class. And I'm sure that I will get to know many of you in a bit more detail in future classes. But yeah, I'm happy to be here, and hopefully we create a nice group dynamic and a place where you can just learn efficiently. Okay, so we sort of spoke about this question already, so I'm going to just kind of zoom in for a second and actually bring these questions across. And what I want you to do is I want you to do these questions for me. I was talking about this during the lesson or during the previous thing. I want to see, can you answer these questions for me? And I'm going to give you 3 to 4 minutes to try and work out the answers to these questions. And then I will answer them with you. Okay. Ozan, can you see the screen okay? Is it good? Okay, great. So I'm going to give you a little bit of time, see if you can answer the questions. And then we'll have a chat. If you've got a question or you're stuck on something, just pop it in the chat and I will give you a hint or I'll give you some guidance. Or if you feel like you're just winning at life and you're smashing this, just give us a little thumbs up in the chat stream, just so I get a sense of whether I'm going too fast or too slow, etc. Thanks, Elzan. Okay. Okay, to my students out there, are you ready to rock and roll? KK, have you got an idea? Do you think it's summer or winter in this graph? How would we tell that? It's actually a good question. I would imagine in summer, it would stay hot later in the day, and in winter it would get dark earlier in the day, I feel a bit like this should be, okay, I have my idea. It's a little bit open-ended, that first question, but I have an idea, because I think when the sun runs out, it starts getting colder, is kind of what I'm thinking. Okay, so I'm going to answer these questions. So I'm not 100% sure exactly if it would be summer or winter, because I mean, the graph is a little bit ambiguous about that. But what I'm thinking is, if you look at how it's going to get hotter and hotter and hotter, if the hottest point of the day is at 3 o'clock, does that make sense with our intuition for summer? I think it does, because, the sun obviously is hottest towards the middle of, so I would say my intuition says summer. It is a little bit dependent on where you are in the world, I guess. If you're at the equator, or if you're in Joburg or Cape Town, the sun tends to set at different times. I know in Durban, it sets much earlier than in Cape Town. So in some senses, the question is a bit open-ended in the first one. The second one, though, is a lot easier, because we want to know, where is the highest temperature recorded? And the highest temperature is recorded, well, on the graph where it gets to the highest point. So that for me would be the highest temperature, and it occurs at that time. So at what time of the day was the highest temperature recorded? It was recorded at 3 o'clock in the afternoon. And notice how I underlined the important words, especially if English isn't your first language. It's really important to hunt for the important keywords. So what time of the day was the highest temperature, and what was this temperature? Well, to see what the temperature was, I need to go to the temperature part. So that would be 21, 22, 23 degrees Celsius. Okay. During what part of the day did the temperature rise, and during what part of the day did the temperature drop? So again, if I'm talking about the time of the day, well, obviously the time of the day is the character on the horizontal axis. So let's underline the important bits. During what part of the day did the temperature rise? So it feels to me like really that's the first point that I have any information, which I think is 1 in the morning. And all the way until I get to the highest point, the temperature is rising. Sure, it's rising more steeply at different points, but it feels to me, at least from what I'm seeing on the graph, is that from 1 a.m. all the way up to 3 p.m. or 1500 hours is what this graph is saying. It's literally rising. You can see that it's going up. And during what part of the day did the temperature drop? Well, pretty much every point after that. So it's going to be from that, and we can't really see past that point. So the temperature was dropping. So dropping, oh, am I spelling it wrong? Math teachers and spelling. Okay, so from 15, so from 3 o'clock all the way to essentially 12 p.m. During what part of the day, or what part of the period when the temperature was rising did it rise most rapidly? So in this case, we're looking for the place where the graph is steepest, where it feels like it's shooting up the most. And to me, if I look at it, this part of it, if you think about a roller coaster, or you think if you were climbing a wall, I think between that point and that point, that would be the steepest climbing wall. And so now I know that it's between these 2 points where it's the steepest from my visual intuition. But what is the time? So I have to count. So 10, 11, 12, 13, or 1 o'clock. Let's see how they've used the 24-hour scale. So I think the temperature was rising from 13 up to 15. Or 1 p.m. to 3 p.m. if you, even I get confused with the 24-hour clock sometimes. During what part of the day did the temperature drop the most rapidly? We're looking for now the steepest roller coaster, and it looks to me like, excuse my wiggly hands, it looks to me like that would be over here. And that would be, if that's 8, that's 7, that's 6. or 1800 hours. And so it would be from 18 to, or from 6 o'clock to 8 o'clock at night. Okay, and so that's the type of questions that we can be asked. I'm just going to check the chat to see if there's any questions. Otherwise I'm going to move on. Okay, now this is about car sales. So this question is about car sales. And what I want to do is I want to ask my audience, have you heard about discrete or continuous data? So just give me a thumbs up, or actually say yes if you've heard of it and say no if you haven't. And if you could just put that in the chat, that would be super awesome, because then I will know if I need to give you a little bit of explanation on the difference. And then we can all, what you need to know. Arson in Belleville, have you heard, have you heard about discrete and continuous? No, sir. Sonelo, you haven't heard about? Nope. Okay, fantastic. Then I am the person to help you out. Okay, so normally speaking, discrete data is data that you can count or occurs in specific amounts. And a good example of discrete data would be like shoe size. You know, you don't, if you measure the length of your feet, it's different. But when you're buying shoes in a shop, you only really get like 8, 8.5, 9, 10. It's sort of countable. If you're counting something, generally we say it's discrete. You can't have 8,33337 shoe size. You only have a fixed number of choices. But if I'm measuring your feet, if I'm taking what's the most accurate measuring thing, some sort of electron laser thing, and I'm measuring your foot and it's 23.77789 meters, you can measure it to the smallest fraction. So probably the easiest way to think about this type of data is that I'm looking to see, can I count it? Then it's probably going to be discrete. If it's can be broken up into really, really small fractions, or it can take on any arbitrary value in an interval, it's continuous. So based on that explanation, I want you to try, maybe it wasn't the best one, but I want you to try and do A for me. And then I also want you to try and do, actually, I want you to try and do the whole thing. So first of all, do A, I'll mark that fairly shortly. And then I want you to try and do the rest of the question. And I'll give you about 3 or 4 minutes to try. Chonero, welcome. I am, for some reason, I wasn't picking up your name. Dalen, also see you on the corner of my screen. Dalen, what do you think? Do you think it's discrete or continuous? Are you feeling brave? Do you want to pop something in the chat? Apologies if I'm looking, I have 2 screens here, so I keep looking up my picture on the lower right-hand corner where my screen is in front of me. But like everything, you practice and you get better. Austin, what do you think about this data? What do you think do you think this data is discrete or continuous? Ah, discrete. Yes, I agree with you. And the reason I agree with you is that if I think of the story, the story of this graph, and again, I really emphasize this, the story of this graph is it's about car sales, okay? And the story of it, you know, on the horizontal axis, we have time, or the months as they go by. And on the vertical axis, we have the number of cars. And you can't sell 5,7778 cars. You can only sell, say, 25 or 30. So this is definitely going to be discrete data. And if you were counting people or elephants, that would also be discrete data. Okay, do you need a bit more time to answer this, or are you ready for me to mark it with you? I'll give you a little bit more time because I think I was so excited with that discrete data that I almost got carried away. I'm just going to draw some lines on the screen and you can see if you agree with me. So August goes to there. And then that seems related to that. And that seems like an important word. Okay, let's do this. So how many cars were sold in August? Well, we have to go to where August is, and you'll notice that there's a lovely little dot. Now, something else to realize is that on graphs that have discrete data, you'll often see dotted lines between them. And what that's saying is that, they're only really taking the survey at the end of the month. They're only, at that point, that data hasn't really been gathered. That's just sort of linking the things together. But it's really giving you a sense that the dots are the important data points in the story. Okay, so where were we? August, if I trace it up, August seems to be, there were 30 cars sold in August. Where were the maximum and minimum? Well, that seems to be the maximum and that is the minimum. So if I look at, if you think about points are just relationships. They're showing you the relationship, between two things. And the lowest number of cars is related to September. So we're going to say September, and the maximum occurred in December, maybe when people got their bonuses, who knows. How many cars were sold in
Can you hear me?
Alzan, sorry about that. Can you hear me?
Oh, sorry, I lost you there for a while.
A minute. Hey, from KK. Hello. Okay, sorry.
Sorry, I think it might have been my network. Sorry for barging in.
No, not a problem. Okay, so can everybody see, can you see the screen or yet or not?
No, I can only see you.
Okay, let me put my screen back in because I think that will be a much better experience.
There we
How's
go.
that?
Got it.
Awesome. Okay, thank you very much. Thank you to my loyal students out there too. Let's make sure I got the chat window open. Aha, Arsen is on form today. KK in the house. There we go. Okay, so let's finish this up here. So if I look at these questions, the difference was, so this was 30. So 25 and November was 30. And so the difference is just going to be 5 cars. So how many more cars were sold in November than in July? There were 5 cars more. So 5. During which months did car sales decrease? Well, it does depend on if we're talking at the end or the beginning of the month, but I would say September, you can clearly see, let me clear the screen because it's a bit cluttered. It only really decreased in September. Everything else has an upward thing. So yeah, we're going to go with September. And then when would you say the car sales generally, would you say that car sales generally improved over 6 months? Explain your answer. Generally improved, yes. If you look at where we were and to where we ended up, I mean, in those 3 months, over 6 months, okay, it's asking you what is the behavior? And I would say generally improved. Well, they took a little dip over here and then they went up. If we look at where we started on the graph and we look at where we ended up, the trend line between there seems to be upwards. And so I would say, yes, it's generally improved. There was one bad month where maybe people were just, maybe there was a COVID thing and, things were closed and it affected the economy, but the general trend is going up. Okay, let's move on and let's just quickly get a sense of the time. So I think we'll go for another, what time would we actually start, Ozan? If you could just give me a sense of that and then how long we should continue, but I'm happy to carry on go.
So I think we started past.
Perfect. Okay, so we're about halfway there. I'm going to leave the question up on the board for everyone. And if you could give that a go, please. This is what we call a distance time question. I can almost guarantee you there will be a distance time question on your end of year exam. We really like them as teachers. They also come up in physics a lot. And so I would like everyone to try and get the answers to these ones. I'll leave it up on the board for you. And then I will bring my teacherness to the question. Let's have a look. No, wait, I'm moving the screen, sorry. Is that a bit easier? Maybe it's a bit bigger that way. Okay, so this story is about Margaret cycling, and it's a travel graph, the distance from home on the cycle ride. And the first question is about after 30 minutes. Okay, pop those answers into the chat if you feel like you've got them. I'll give you another minute or so, then we're going to go through them. Okie dokie. Are there any answers? Okay, so let's just go through this briefly. How far had she cycled after 30 minutes? Now, they didn't give you 30, but it's hiding there between 20 and 40. And so it looks to me like after 30 minutes, she's 6 kilometers from home, which is not a bad speed if you think about it. So we'll go 6. After 60 minutes, Margaret stopped for a rest. For how many minutes did she stop for a rest? So I think if her distance is no longer increasing, and remember the vertical is the distance, it starts at that point and it continues to that point. And it feels to me like after that, she starts coming closer to home again. It's almost like she's riding home from school or something. So she rested between minutes 60 and 80, which the difference would be 20. How far did Margaret cycle in total on her ride? Okay, so now we have to think, well, it was sort of divided up into two pieces. So in the first bit, let me get rid of them, all the bits and pieces. In the first bit, it went up to here. And that must be, you can see it's clearly in line with 12. But is that all she did? Nope. She also cycled the 12 Ks. Well, essentially she was 12 Ks away from home and she got back there again. So she actually had to do it twice. And so her total would be 24. So 24 kilometers would be the total. And we should also put the units because that's the distance we used. Okie dokie. Again, I'm just going to give you a chance. Look, I'll look at the chat. If you want me to give you a bit more detail, a bit more discussion, please let me know. But otherwise, I think you guys can have a crack at this. These questions are all now proving to be quite similar, and that's the idea. We're practicing. Let me just choose the text mode, and I will make this a bit bigger for you, hopefully. Apologies if you got a bit dizzy there. Okay, so this is the story of James, and his journey is a bit different. Give it a crack and see if you can get the answers to that. Now I'm going to stand up for a stretch because you don't want to sit for too long. There we go. Sure, Austin's on fire. Anybody want to give Austin some competition? Okay. So this question, a little bit, yeah, I think we can give it a go now. So how many minutes? It says James. Well, first of all, let's look at the axes so we don't get too confused. Distance in kilometers from his home. So that's the vertical axis. And time again on horizontal. So these are always called distance time graphs. On the way to the swimming pool, he stopped to talk to a friend. Here is the distance time graph for his journey. Now, you can just see the flat bit over here. He's clearly where he was talking to his friend because he's not traveling, he's not doing any distance. So for how many minutes did he talk to his friend? Well, we have to figure out what's over here. So 11, oh, actually, no, this is minutes. So we need to think about how many increments. 15, it looks to me like 15-minute increments. So that would be 10:30, 10:45, 11, 11:15. So he was talking to his friend from this time to that time, which for me is 45 minutes. What is the total distance from James' home to the swimming pool? Okay. So the total distance, basically, he started here. And it says that he's got the swimming pool up here because there's no mention of him going home. And so how far has he traveled between 10 o'clock and 12 o'clock? Well, he's traveled 5 kilometers. And that's it. So, after you've done a couple of these, they do start to look quite familiar. Now, the next one is going to be a bit harder. This one, I'm going to ask you some questions, but then you are going to complete the graph. You're going to add something onto your graph. So not only do you have to answer questions, I tell you a bit of a story, and you're going to say what happens in the remainder. And so I'm going to give a little bit more time for this one because that takes a bit more thinking. You're not just, you're interpreting and then you're creating. So take a moment, read everything, and then think about answer A and B, and then think about what does the graph look like after A and B. Hmm. Okay, so let's try and do the first bit, so then I'll give you a bit more time for the next one. This resting question, we've got this, because we can see over here, when the graph is not going up anymore, he's resting. So the question is, how many minutes did he rest? Well, that we need to know our scale. So what is our scale here? 1, 2, 3, 4. It's 15-minute blocks again. And since it's one block, I am going to confidently say, oh, this is a very thick marker, but you get the point. This is 15 minutes. Find his distance from home at 1:30 p.m. So let me get 1:30. Now 1:30 is going to be halfway, so it's going to be over here. How is distance from home? So I found the 1:30, and now over here, that's going to be in line with 15. So he was 15 kilometers from home. Okay, so now the last bit. The man stopped for another rest at 2 p.m. So let's find where 2 p.m. is on the graph. You just have to take your time to kind of look things up. And so let's make sure we find 2. So there is 2 p.m. He's 20 kilometers from home. So what will the rest of this graph look like? So I'm going to draw the rest of the graph in red so it stands out. It says he rested for 2 hours. So really, this should be flat from 2 until 4. It should be completely straight. So let's try that again. And flat like that. Now this won't be on the graph, so it'll be there. And then he rested. His man stopped for another rest at 2 p.m. He rested for an hour. Oh, I've made a boo-boo. So he didn't rest for 2 hours. He rested for 1 hour. So he rested for 1 hour from 2 until 3. Make sure I'm in line with 3. I am. Then he cycled home at a steady speed. It took him 2 hours. Okay, so we know he has to be back here, which is basically in line with 0 at 5 o'clock. And it was a steady speed. Now, what that's going to mean is that the line is going to not be suddenly steeper and shallower. It's going to be one straight line with what we would call a constant gradient. Now, I know I didn't do a perfect one, but it's going to be a straight line coming straight down like that. And so that's the story of that distance speed time graph. And have I completed the graph? At 5 o'clock, he's 0 kilometers from home, so he's back home. Okay, so we have about 20 minutes left. I'm going to introduce a different type of question now. Now, this question actually doesn't really have a graph per se at the stage. All it has is points, but these points are like little relationships, and we call this a scatter plot. And a scatter plot is just basically a whole bunch of data points and their relationships being showed with 2 axes together. And so I think based on the thinking we've done so far, you guys can give that a go. The characters in this story are, well, height is on the vertical axis and weight is on the horizontal. And so there are people whose measurements we have taken. And so I want to see, can you read off this information by yourself? This is the warm-up to the next lesson, which will be about how to create your own graphs, how to put information onto your own graphs. But for today, we're just reading information off. So I guess we have to find where Tim is. We have to find where Chris is. And we have Jane. So these are important names. What is the scale? It's weight. And the scale doesn't start at 0 here. I think it starts at 20. So something important, whenever you're interpreting graphs, always look at the scale and its markings. Otherwise, how do you know kind of where everything is? So you can see that like Anne's in line at 25. And the height, the blocks are each 5 centimeters. So that should help you get started in that, unpack it. Oh, Austin is on fire again. Okay. Let's have a look. Let's give a moment or two more and see if I agree with your answers there. Let's see. So, what height is Tim? Well, first I have to find Tim. Where are you hiding, Tim? Aha. Tim is hiding up here. Now, I want to know his height, and the horizontal axis is not height, it's weight. So, it appears that Tim is 120 centimeters. Okay, so that's good. We've got Tim. What about Chris? Let's change the color. What is Chris's weight? So in this case, weight is on the horizontal axis. And now it's not easy, so I have to count 25, 26, 27, 28, 29 kilograms. So 29 kilograms. Who is the same height as Jane? Well, first I have to find Jane. So let's get rid of this. Where are you, Jane? Makes me think of See Jane Run, the reading books. Okay, so Jane, how tall are you? You are 110 centimeters tall. And who is in line with you? Wobbly hands. Who is in line with you? It is Carl. So Carl is a person. Do I agree with you? Let's have a look. I agree. We're the same. Who is the tallest of these children? So again, if height is the vertical axis, Ben seems to stick out. Let's see if I can. So Ben. And Ben is 130 centimeters. And who is the heaviest of these children? So the heaviest would be the furthest across, would be like going in that direction. And it looks like John is going to be the heaviest. And how heavy is John? John is 39 kilos. So he's probably about a grade 6 or 7, 8 boy, give or take. So 39 kilograms. Okay, so you can see like it's not too bad. And oh, sorry, I'm making things up. I'm putting the values in there. I lost my concentration for a second. So who is the tallest child? The tallest child is, we said, Ben, and the heaviest child is John. We didn't even want the values. I was going one step too far. Okay, we're almost at the end here. Let's leave that one out. Let's do another one like this. And this is about cell phones and using your cell phones, but it's a couple of years old. Can you see the question okay? I know it's a little bit. So this is another one where it's sort of a scatter plot. There's a whole bunch of points, and we're simply just trying to extract the information. But the story is about cell phone spending. And on this axis, we have total bill, how much it costs. And over here, it's number of minutes used. It seems like it's before the time of WhatsApp and all those things. I don't know too many people who phone too much these days, but that's the context. So give it a go, see if you can do that. And then we probably will go to our final closing question for the day, which will be a fun quiz. And I'm hoping you'll find it fun. It's a tool called Quizzes, and my classes have always loved it. Okay, who's going on? yeah, it's interesting to think people will watch this afterwards. Hopefully they will find it useful. I'm just going to highlight keywords that I see at least. Let's see if I can change my angle a little bit. I probably should have actually had it a little bit lower. Okay. Okay, let's do this one. So, so we have who had the highest bill, and I think I've kind of given the thing away there. It would be Sarah, because she's in line with the highest point there. Who talked the least? Well, the person who's used the least minutes would be Mikey or Mickey. And which friend chose the most expensive provider? Now that's a little bit harder because let's see how many minutes. In order to know, it depends how they phrase the question. So Tandy has basically, I mean, she's used a lot of minutes and she's hardly paid anything. So she must be using a very cheap provider. Let's just see who. So Mikey had the lowest bill and used the least minutes. Okay. So in some ways, we really want to know for each of these people what the cost is per minute. So if I look at, let's make a little table here, Sarah, Tanya, James, Mikey, Tandy. And so if we look at Sarah, she used 75 minutes and it cost her 25 Rand. And so I'm going to go 75 divided by 25. Tanya used 60 minutes and she paid 60 Rand and used 10 minutes. James was 30 Rand for 15 minutes. And Mikey was 10 Rand for 5 minutes. And then Tandy, who definitely got the best deal, was 20 Rand for 20 minutes. So let's have a look at who had the cheapest provider. So Sarah was 3 Rand a minute. Tanya was, well, she was playing a lot. James was 2 Rand a minute. Mikey was 2 Rand a minute. And Tandy was 1 Rand a minute. And so the person who chose the most expensive provider was definitely Tanya. Now, I don't know if you had to do all that working, but it was good to give you a feel for what's going on here if you're comparing total bill and then the number of minutes used. What was the total number of minutes used by all friends combined? Well, the minutes was just the bottom part here. So it's going to be, let's get a different color. It's going to be 25 plus 10 is 35, 50, 55, 75. So 75 minutes. And which friends use the same provider? Well, those are going to be the ones that have the same rate. And the only two that have the same rate are the ones that are 2 random minutes, which are James and Mikey. I'm just seeing that correctly, as long as it's not more than 2 M's. Yeah, awesome. Okay, we've got 8 minutes left, and I'm going to draw this lesson to a close. I want to make you aware of a place where you can practice, and then we're going to do what's called the exit ticket. So Watobe has an app. Actually, Alzan, I think you're going to show, are you going to show them the app afterwards, or am I going to do it? And basically, this app itself, let me...
So Peter, I'm more than happy to do it.
You do that, okay.
Yeah.
Perfect. So all I'm going to finish with now is I'd like you all to give this a try. And you may not finish it all now, but I just want to check if you guys can get on. So if you guys would just go to that website address and enter that code, you might actually want to do this after the lesson, after we've showed you the app, but I just want to check that you can get in. So will you all please check that you can get into this quiz? And then I will and I'm going to ask you to do that for homework. And then I'm going to hand over to Alzan to then take you through the app. So I'll show you on a browser what it should look like if you go in how you start this. So let's just say, let's open another tab here. In the meantime, you can actually just go over yourself and see if you can. Let's see, I'm bringing the orange to the screen. Let's see. Okay, so if you type in join my am I still with you? Oh, there we go.
You were away for a few seconds, but we can see.
Okay, so then you enter 50355614, and then you should get a quiz that looks all kind of funky, and you can put your name in there and give it a go. And it's based around the types of graphing that we did today. And so I'm going to leave you at that and hand over to Alzan. Thank you, Alzan, for being my co-pilot. And I'm sure the next time it'll be a lot smoother. It's always like that.
I think so as well, definitely.
Yeah. So I'll stay on the line or do you need me to stay on the line, or should I take my bow now?
You can stay on the line, then we can chat afterwards as well.
Okay, cool. All right.
Awesome.
Over to you.
Awesome. So yeah, Peter, thank you so much for this lesson despite all the technical difficulties.
Yeah.
Awesome, Kiki, Tuanelo, are you guys still with us? Please share some emojis. How are you guys feeling after this lesson? We'd love to see some. This is my reaction from today's lesson. We've got a thumbs up from
Oh, there we go.
Well done. Kiki asks, and how are you guys feeling?
I'm feeling pretty good, actually. I feel like Alzan, you're going to be like the hype person, and I'm like the. No, I mean, it's obviously you definitely want as much engagement as possible, but I think whenever you do something new, it always, and I've done enough tech stuff to know that sometimes this happens, and you just roll with it. But I had fun. I mean, I think that came through. I'm used, I hope it was helpful.
Yes, of course. So guys, I'm quickly just going to share with you the grade 8 graph. So basically, this is, let me present to you guys. This was our first lesson with Peter and myself. I will be your mentor, and you will be seeing more of us again during these next few weeks. So Wednesday is your next class. But before we go to Wednesday, I just want to say well done for being here today and completing your interpreting graphs. There's a horse you can see there at the top, just to say that, we've started running, and at the end, there will be a reward for you guys, okay? So you must just continue to run no matter how tired you get. And please don't feel afraid to sometimes, if you just need to stop and rest, if you need to ask questions, ask questions like Peter said, he's more than happy to answer. Okay. So just a shout out for next time. And then I'm sure you guys know the leaderboard. Can you give me a thumbs up or thumbs down? Have you heard of this leaderboard before? Tuanello has heard of it. Arson, have you heard of the leaderboard? So you can either use, you can go into the chat.
You said yes.
Oh, you have. Yes. Awesome. Sorry. So Peter, I'm not sure if you've heard of this, but basically every week we see how many lessons has been done on the Watobe app. And then the learners who's done the most lessons get rated first until the fifth lesson. So we'll be seeing more of this. I think from next week we'll be starting to use the leaderboard. And you guys have been on this lesson today. So I think your names might be on here first. Okay. So make use of this. And where do we go? We obviously go to the Watobe app. So as you choose your topic, you will find graphs. And then as you click into graphs, underneath interpret real world graphs, you will find read line graphs.
They can be two actually. So it's the interpret real world graphs and read line graphs are the two things that are relevant. They can leave the distance time graphs for now, even though they've done some today, just the first two.
Okay, so read line graphs and the
no, not distance time, just interpret real world graphs and read line graphs. They're actually two separate little areas.
Yes. Okay. So you want to do the first one.
The first one and the interpret real world graphs and read line graphs are two little sections. They can do both.
Okay. I think I have you on this one. Okay. So do you guys understand? So like this yellow, can you see interpret real world graphs? So there's another subcategory that's also called read line graphs. Am I correct?
Yeah.
Okay. Yeah. And they must do both of them.
Yeah.
Awesome. Okay, do you guys have it? So basically this one and the other one.
Yeah.
And then, yeah, that's it from us. Do you guys have any questions, any comments?
Yeah, and if they want anything in particular, like if they want a particular emphasis, they mustn't be afraid to just say it. We can always adapt as needed. So yeah.
Yeah.
Based on the general content of graphs, if that makes sense.
Of course, of course.
Yeah.
So do as many as you guys can before Wednesday. But Wednesday we'll get back on it again, and then Peter will take us through the next lesson. Okay. Okay, guys, that's it from us. Thank you so much for joining. Take care of yourselves. Enjoy the rest of your evening, and then we'll see you guys again on Wednesday.
Cool. Ciao.
Bye-bye.